work where you can still ask questions. So, we're taking the derivative of this stuff right here. But it is not just a straight chain rule anymore. We've got something out here that involves an x. So, my pen here. This part right here involves an x. We've also got this stuff over here that involves an x. They're not really related to each other. So that is a product rule right there. But within the product rule, we're going to have a chain rule because we've got this inside stuff right here. So this is where it starts to get a little more complicated because we've got to use both rules here. So whenever we take the derivative, we are going to do f of x, which is, let me try to color code it here, is our 3x squared. And we have to multiply that by the derivative of the second part, the stuff in the blue box. But to take the derivative of the stuff in the blue box, we have to use the chain rule. So I'm going to take the derivative of the outside part, which is to the 4th power. So that's going to be 4 times the stuff to the 3rd power. And then the stuff on the inside, 2x minus 1, stays the same. And what else do I have to do? Multiply by the derivative of the stuff on the inside, which is 2. Now, you feel like you were done. You are only halfway done, right? Because this is just f times g prime. Now we have to do g times f prime. So we will have plus 2x minus 1 to the 4th power times the derivative of 3x squared, which is 6x. As you can see, it's going to be really easy to forget to do part of that because you've done so much you feel like you're done. But are we okay here? Does this make sense? This is your f. This is your f prime. This part right here is your g prime. This is your g. We just had to do a little chain rule on that g prime part. So, they're gonna simplify this here if it's multiple choice. If it's free response, technically you can stop here. But all of this stuff is multiplied together. You got a 3x squared, you got a 4, you got a 2 over here on the end. You can put all of those things together. So 3x squared times 4 times 2 is going to be 24x squared, and then 2x minus 1 to the 3rd power. Plus, they're probably just going to write the 6x up front here, and then 2x minus 1 to the 4th power. They will probably not stop here. If it is a multiple choice question, they're not going to quit at this point. So what you should be noticing, what you're looking for, you might not be looking for it because we haven't done a lot of problems like this, but I've got a 2x minus 1 here, and I've got a 2x minus 1 here. Okay, it is almost having like a different variable, like a y to the 3rd and a y to the 4th. I can factor that out front. Okay, I can take the lowest exponent. So there are 3 of these here. There's 4 of them here, so I could take out 3. So I'm going to have out front, I will have 2x minus 1 to the 3rd power. So whenever you factor like this, essentially what you are doing is you're dividing that whole term by 2x minus 1 to the 3rd power. and you're dividing this whole term by 2x minus 1 to the third power, right? Okay, here. So, right here, that just cancels out, and we get 24x squared. Over here, they don't all cancel out because I have 4 of these things on top. I've only got 3 of them on bottom, so these 3 cancel with all but 1 of these here. So right here I get 6x times 2x minus 1.
So you don't have to do anything to the 24 and the 6. Just do that to like 2x minus 1 when you take out.
You are dividing that because it's all like one term that's multiplied together. So it's kind of like having like a 24x squared y to the third. If you divide that by y to the third, you cancel those two things out and you don't mess with the other stuff that doesn't match it. Does that make sense?
Would you have to distribute the 6x stuff?
Yes, we will distribute our 6x. We'll just leave this out front, 2x minus 1 to the third. And then, so we got 24x squared plus 12x squared plus 6x. And we could put the x squareds together. Ugh. Minus 6x. 2x minus 1 to the third. And 36x squared minus 6x.
Will they leave like that?
Possibly. Possibly not. They might leave it here. What else could you do? Can anything else go with the 6? An x. So they might, what they might do is they'll take a 6x out. They'll probably write this first, 6x minus 1, like that, and then have the 2x minus 1 to the third. So they could. You never know. You never know exactly how far they're going to go. Yeah.
So FRQ, where
FRQ, right here. Now, most of the time on an FRQ, you would need to do a little something else with it. So it might help to at least simplify it a little there. But they like to put these on multiple choice, so yeah. But it's okay. We can do it. The calculus part of it, if you're just careful, is not too bad. It's a simplifying that can get difficult, but we're going to get better and better at it. All right, let's look at a couple more. I think these are actually probably easier because the simplifying is not as bad. So if you see ease or trig, I think they're a little bit easier. They still, in this case, are going to require a product rule. So we got our 3x to the fourth. There's our f, and our other part is our g. I might not should call it f and g since I have called these equations f and g, but I'm going to do it anyway. Alright, so if I'm using product rule here, I do need to be alert. Which one of these has got a chain rule inside of it? That e to the 2x. That's your little, it's a tiny chain rule. It's so easy to miss it because it's just little, right? So I would do f of x, which is 3x to the fourth, times the derivative of g. Here's where the chain rule comes in. So the derivative of e to something is e to that stuff, right? But that stuff is our 2x. What else have I got to do for the chain rule? Times 2. Okay, then we'll have plus the g of x part, which is just e to the 2x, don't take the derivative there, times the derivative of 3x to the fourth, which is just going to be 12x to the third. They'll do a little simplifying on this. They'll clean it up a little bit. So you've got like 3x to the fourth right here. could be multiplied with that 2 right there. So that'll be 6x to the 4th e to the 2x plus 12x to the 3rd e to the 2x. How are we doing there? Okay, they might stop here. What else could you do if you wanted? You can factor out more than 1x. You can take out a 6x to the 3rd. What else could you take out? E to the 2x. So you could take out a 6x to the 3rd e to the 2x. There. So lots of things could be factored out. If you do that, remember it's like you are dividing both of these by 6x to the 3rd e to the 2x, 6x to the 3rd e to the 2x. So on this first one, e to the 2, or both of them, e to the 2x is canceled. Here, 6 divided by 6 is 1. You would cancel out everything except for an x in the top right there. And then here, the x to the 3rds cancel, the e to the 2x is cancel. 12 divided by 6 is 2. They don't always do that, but they do a lot of times. So be looking for those greatest common factors. In particular, try to get your answer to match whatever's in the back of the book. If they pulled it out, you'll kind of see, oh yeah, that looks like they factored this stuff out. All right, questions on 2? All right, 3. We've got 2x plus 3x times sine of 3x. What all is going on here? I'm assuming we're going to need the product rule somewhere since that's what we're working on right now. Where do I need the product rule? That 3x times the sine of 3x. Do I need a product rule or any special rule right here? When I start taking the derivative here, the derivative of 2x is just 2. Don't have to do anything special right there, right? But over here, you're taking so your f here is this part.
Oh.
And your g is this part. Okay. And then which piece of that needs a chain rule? It's a sine because that 3x, you don't have just the x on the inside, you got the 3x. So that part's going to need a chain rule. So when we take the derivative of the 2x right here, it's just 2. We don't, it just hangs out front there. Then we've got to do the more complicated derivative over here on this side. So we'll have 3x times, this is where the chain rule comes in. What's the derivative of sine? Cosine of the stuff. The stuff stays the same here, but what do I have to do? Times the derivative of the inside, which is 3. Yeah, but we're only halfway, even though it feels like you're done. This is what everybody does wrong, is they just quit because they feel like they've done too much already. So then you've got to do your g of x, which is sine of 3x, times the derivative of the f of x, which is 3, right there. Unless you really run into some crazy, trig identity stuff, these are usually some of the easier ones to simplify because they don't usually go very far with this. So the 2 just stays out here. You got 3x cosine 3x times 3, so you can multiply this 3 and this 3 together, so you will get 9x cosine of 3x. And then they'll just probably write this as plus 3 sine of 3x. And most of the time they'll just stop. You won't see them go further. So as much as we dread C and trig a lot of times, they actually are probably easier than some of the others. Like number 4. I made this one multiple choice for you, so hopefully I didn't mess it up because I did just make it like the other day. So this one's not been tested yet here. I've made this one multiple choice so that we can like get a feel. This is what it looks like on the exam, right? Given the function f of x equals x squared, square root of 1 minus x squared, write an expression that gives the instantaneous rate of change of f of x for any value of x. When it asked for that instantaneous rate of change, what's it asking for? F prime of x. It's just asking you to find the derivative is all it's asking you to do here. Try to throw some of that language in there sometimes that they'll give you. So this is going to be a product rule with a chain rule inside. I would, before I do anything, change this to make it x squared times 1 minus x squared to the 1/2 power. So whenever we take this derivative, that x squared is my first part, my first function. My 1 minus x squared is my second part. And which piece of that needs a chain rule? That inside parentheses stuff right there is 1 minus x, right? So that's where the chain rule is going to come in. So we will do x squared times, we got to do the derivative of this stuff. So we got 1/2 the stuff to the negative 1/2 power. We'll put the stuff in there. We don't mess with it. And then I got to multiply that by the derivative of the stuff on the inside. What is that going to be? A negative 2x. Make sure, it might even be a good idea here to use some parentheses. You want to make sure you're not doing minus 2x right there. Because when you end up with that negative, sometimes you make it look like minus. Alright. Plus, we got our g of x stuff, which is 1 minus x squared to the 1/2. And our derivative of our first part is just 2x. Okay, technically, FRQ, you can stop here. But they're not usually on FRQ. They're usually multiple choice, as we see here. So, to clean this up a little bit, I would put, I've got an x squared, I've got a 1/2, and I've got a negative 2x. I'm going to multiply all that together. So the 1/2 times the negative 2 is going to give me a negative 1, and then I'll have 3 x's. So I've got negative x cubed, and then 1 minus x squared to the negative 1/2. And then over here, we're probably just going to put the 2x in front here. Okay, there are some options for how to deal with this. You can see clearly from our answer choices we are not done, nor are we like close enough to be able to distinguish like, oh, this is going to match. I'll show you the way I like to do these the most. You certainly can send this negative exponent back to the denominator, and you can get common denominators for that. Here's what I like to do. I like to treat it like the first problem that we did. Okay? Because I am seeing that I've got a 1 minus x squared and a 1 minus x squared. I've got that same term in both places. Okay? So what I'm going to do is I'm going to factor that out front. So I'm going to have 1 minus x squared, and I've got to take the lowest exponent, which is weird here because it is a negative 1/2, but you can do it. Okay, so what that means is I'm dividing both of these by 1 minus x squared to the negative 1/2. So the first term is easy because 1 minus x squared to the negative 1/2 and 1 minus x squared to the negative 1/2 just cancel each other out right there. So I got negative x to the third. You can use a parentheses instead if you want. I just know I'm going to end up with another parentheses, so I used a bracket instead. But a parentheses is fine there. So over here, these don't cancel because this is a positive 1/2 and this is a negative 1/2. So several different ways to think about that. But whenever you're dividing here, you can subtract your exponents. So if I subtract my exponents, I'd be doing 1/2 minus negative 1/2. What is that going to give me? 1, because the minus the negative becomes positive. 1/2 plus 1/2 is 1. So this is going to be 2x times 1 minus x squared to the first power right there. Obviously, you don't have to write that first power, but I'm going to here just to be very clear about what happened. Another way to think about that is this one goes up to the top, and then you could add them together. 1/2 plus 1/2 gives you just 1. And so if you factor out the lowest exponent, that positive or negative, this should happen every time where we don't have fractional exponents anymore for that part. So I've got 1 minus x squared to the negative 1/2. And then I've got negative x to the third. I can distribute right here. So I get plus 2x minus 2x to the third. I can combine some like terms here. Negative 3x to the third plus 2x. All right, so looking at my answer choices, do you guys see it? Which one's it going to be? It's going to be D, because I can send this right here back down to the bottom. That'll make this square root of 1 minus x squared there in the bottom. And then they just wrote this as 2x minus 3x to the third instead of negative 3x plus 2x. And you kind of have to use your answer choices to guide you in that last part because there's no rule that says that you can't leave it like this. We just know our answer choices don't look like that.
Sorry, could you just do common denominators instead of going out that?
You can. Yes, that's another option. And if you prefer it, you can. That's perfectly fine. I find this way kind of helpful when we like get to quotient rule. You almost have to do it in quotient rule or you get these like giant like complex fractions. So I kind of like to do it this way, but you definitely could do common denominators. Okay. I want you guys to do a couple problems, and then we're going to come hard to recognize it's a chain rule inside of a chain rule right here. Good news about ones like number 5, they're not difficult to simplify. So in order to even be able to see that this is like a chain rule inside of a chain rule, I think it's important to use different notation. This really means cosine of 4x to the second power. Right, so the common notation here is to use like the square right here before whatever you're taking the cosine of. But what it really means is you're taking cosine of 4x and you're squaring that whole expression, right? So to me, it is much easier to rewrite it in this notation. Then you have to think about what the chain rule is going to look like for this one. This is not a product rule because you don't have, I mean, I guess you could make it a product rule. You could do cosine of 4x times cosine of 4x, but I would not go that route. We're looking at that being raised to the second power is our outside. So then if being raised to the second power is the outside, then cosine of 4x is our inside. But is there a more inside? There is a 4x on the very inside here. So you're going to have to take the derivative like 3 times here, right? So whenever you take the derivative of the most outside part, that is just the stuff being raised to the second power, right? So that will look like this. 2 times the stuff to the first power. Obviously that 1 is not really necessary, but let's just put it there so we can think about it. So the stuff on the inside does not change. So this is cosine of 4x. Okay, and then we've got to take the derivative of this stuff on the inside. But keep in mind, like here, we've got a more inside, right? So we're not touching the 4x yet. We're not touching that yet. We're taking the derivative of cosine. What's the derivative of cosine? Negative sign. Important to put some parentheses here so it doesn't look like you're subtracting sign. So it's negative sign of the stuff, right? But we don't change the stuff that's on the inside. It's 4x. And then finally, we got to multiply by the derivative of the 4x, that stuff on the most inside, and that would just be 4. So many. So, now the good news about this is it is generally fairly easy to simplify because you just have to clean it up a little bit. Now make sure you're treating this is like a -1 right here. So you got a 2, you got a -1, and you got a 4. All those are multiplied there. They're just coefficients, so you got a -8. And then this is just to the first power, so it's just cosine of 4x and then sine of 4x. And they usually stop there. They don't usually go any further. They might write sine in front of cosine sometimes. Most people skip taking the derivative of cosine right there. They skip a piece in doing those problems. Okay, questions there? Let's skip 6. It's very, very similar to it's very, very similar to 5. I'll just show you, like, you would need to think of this as 2 tangent of pi t plus 1 to the second power. So anytime you see like that little square on the trig, it's going to be a chain rule. They're probably a double chain rule. Let's skip over here to this one, to 7. I've got e to the -x plus e to the x to the second power. The outside part is the to the second power. the inside part is what's on the inside of the parentheses. This one's super easy to miss the most inside part. What is the most inside part? It's that negative x exponent. You don't have to do it over here because it's just the x, so you don't have to do a chain rule on that part, but right here. So we've got to work through this one. So if we are taking the derivative of the outside, that is 2 times the stuff to the first power. And the stuff on the inside does not change, so don't take the derivative of it yet. It's just e to the negative x plus e to the x. So that's first box taken care of. Now we got to take the derivative of the blue stuff. Be careful right here. There's like a little chain rule right here whenever we do this. So when I do this, I want to open up a set of parentheses because I'm multiplying all this together. When I do the derivative of e to the negative x, then the derivative of exponential is just e to that same stuff right there. And that stuff is my negative x. And then I need to multiply by the derivative of negative x. What is that? Negative 1. Is it okay with you guys if I just put this negative out front for that? Now, I took the derivative of that first part, but I also have plus the derivative of e to the x. What is e to the derivative of e to the x? E to the x. Right there. We are done with the chain rules stuff. Because we did the last box whenever we did this part. So it's a little different than that last problem. Because it kind of happened in the middle of doing the derivative of the blue part. Right there. So we have taken the derivative FRQ. You could stop here. They're probably going to do e to the negative x plus e, and then they'll probably write this is e to the x minus e to the negative x. There's a question like this in the book. Let's see what they do with it. Oh, I did, yes. There should be an x right there. Let me find the question that's similar to this and see what they do with the... Well, I know there was one. That's what I made this question like. Where's E? Oh, there it is. Of course, it's on a separate page. Make me waste time here. Alright. Yeah, I think they're just going to leave it. I don't think they'll do anything different there. I think they'll just stop. I want you guys to have a little more time to work. So I'm not going to do 8 either. But let's just think about what you would need to do for 8. It is just like any tangent line problem we've done, right? What do you need to do first? The point, you just plug in 1 into the original. What makes this fit in this section is for the second part, you've got to do the derivative at that point, and then the third part's to write the equation. So we might do this for warm-up tomorrow instead, actually, because it's a good one to do, but I would rather you guys have a little more time to do